Hello everyone, welcome to Reboot and Rise with MLR. In the last video, we have seen operators up to comparison operators. So let's continue with other operators. So the next operator we have is logical operators. So logical operators, we have a double N, double R and not symbol. So these operators we use to write compound condition, or you can say like combine the multiple conditions and return a Boolean value. So example, assume like I have two variables, card items and hash shipping address. So I want to write some condition like can a customer check out? So my condition is like if the cart is more than 0 items and if the customer has a shipping address, then I would say like he can check out. So how do I write is I'll go with cart items greater than 0 and I'll use double and logical operator and shipping address. Okay, so in this case, like the cart is a half of 5, that means like this is going to be 0. Sorry, this is going to be true, and has a shipping address is a true. So both are true, then I'll get true here. So the result out of this compound condition is I'm going to get true, and that will be assigned to can check out variable. Let us see one more example. Think that I have another variable called as is in stock true and is payment confirmed equal to false. So in this case, like, can this item be, can this product be ready to ship? So in case if the item is in stock and the payment is confirmed is true, then I'm going to write like this is ready to ship. But in this case, so the item is in stock, true, whereas this is false. So this one will return true. This operator will give us a true when both are true. But in this case, this is true, whereas this is false. That's the reason like we get a false. And then the next operator is like logical OR operator. So this will be like either one of the condition true, then we will get true. So example, in this case, like I have a can place on hold. So I'm writing like is in stock or is payment confirmed. So here is in stock is true, whereas is payment is false. But still one of them is true, I'll get true. So this case like either both are true or one of them is true, we will get true here. Whereas not, the last operator not, so basically like this will give whatever we have, like suppose if have a out of stock, sorry, is in stock is true. If we apply this operator, it will give us false. In case if have a false here, then if we apply not, then we'll get true here. Okay, so this is where like the logical operators we use like write more than one condition or compound conditions. So if you want to write multiple conditions, yes, I can go beyond this one. Like if you want to go with another condition, yes, I can go with I can use logical operators. Okay, and then next one we have is unary operators. So these operators we can apply with single operand, that means single variable. So the first two, the plus plus and minus minus are incrementing and decrementing. So here incrementing, decrementing, again we have two types, like one is pre-incrementing, other one is post-incrementing. So pre-increment in the sense like if I apply plus plus before the variable, then we call it as a pre-incrementing. So if I apply variable name and then followed by plus plus, then this is called as a post increment. Similarly, if we apply minus minus before the variable name, then it is a pre-decrement. If you apply variable name followed by minus minus, this one will be post decrement. So what it does is this increment decrement, increment will increase a value of a variable by 1, decrement will decrease a value of a variable by 1. So example, in this case I have a cart count equal to 5. Suppose if I use cart plus plus, so initially in the memory 5 will be stored and that will be pointed by cart count. The moment this line executes, the value of this variable will be incremented by 1. So 5 I have, this will become a 6. then the card count variable will be pointed to the same memory. Suppose if I access later point wherever I want, so in this line after these two lines executes, and if I access this one card count, I'll get 6 here. So after this one example, if I do like a minus minus, what happens is like in the card count I have a 6, but I'm using minus minus, that is a decrement operator. So this will decrease the value of variable by 1. So 6 minus 1, it will be stored 5. So if you access later point, the card count variable, you get a 5 here. And other plus and minus are like a sign operators. So we call it as a unary sign and negation operator. So plus holds the positive symbol and minus holds the negative negation symbol. So example, if I have a int order ID, I mean you don't need to explicitly give plus, but if you give explicitly, it will be treated as a positive only. Even if you don't give, it will be treated as a positive number. So if you access wherever if you access order ID, you will get 1, 2, 3, 4. And example, if you go with refund amount, and if you assign this one minus 500, minus 500 will be stored in the memory. And if you access order ID, I'll get 1, 2, 3, 4. And if you access refund amount, I'll get minus 500. And the not symbol is like generally if you use with the boolean operator. So if you have a true, it will give false, or if you have a false value in the variable, it will give true value. The next operator we have is bitwise operators. So AND or XOR or negate and left shift and right shift operator. So bitwise operator works at bit level, and those are useful for a task like a feature flags or access control. And this left shift and right shift operator works great for multiplying or dividing by powers of 2. Let's see some example. Before that, like let's understand like what exactly the bits. Suppose I have a integer and I want to convert integer to binary. The rule is we have to divide the number by 2 and take the remainders from bottom to top. Example, suppose I have a integer 10 and I want to find out the binary for 10. So what I need to do is like I need to divide that one by 2. So 2 5s and remainder is 0. Again I need to divide this 5 by 5 with 2. 2 2s are 4 and remainder is 1, and then until it becomes 0 or 1. So now I need to take this one from bottom to top. That is nothing but 1 0 1 0 is my binary digits. Let's take one more example. Think that like I have 11, I want to convert this one to a binary. So I need to divide this 11 with 2. So 2 5s are 10 and then remainder is 1. Similarly 2 2s are 4, remainder is 1, and then 2 1s are 2, remainder is 0. I need to take this from bottom to top. So it's going to be 1 0 1 1. Suppose if it is 8 bits, then the rest of the bits are going to be filled with 0. If it is 32 bit or if it is 16 bit, the rest of the bits are going to be filled with 0. Okay. And again, we need to remember one more thing is like there is a truth table for all these operators. So example, suppose I have input A, input B. Suppose if A is 0, B is 0, and A and B is going to be 0. So wherever this you have a AND symbol, right? This bitwise AND, this acts on the bits. If if both are 0, it's 0. If A is 0, B is 1, again it's 0. So you will get only 1 when both are 1. Similarly, A or B. So you can go with both are 0 0, then rest of the cases like you will have 1. And XOR also you can see the table, and negate also you can see this table. Okay. So when we apply bitwise operators over the integer numbers, so they will act at bit levels. And if you get, I mean like in the exam like if you want to find out like you need to convert this one and then see like what is the truth table. So based on the truth table results and the bits that you have, you can easily able to find the solution. So example like I have a variable called as has discount 1 and whose binary is 0001, and another variable I have has coupon 2, whose binary code is 0010. Now I want to write something like both discount and coupon. What I will use, like I will use AND. So this is a bitwise AND operator. So when you use AND operator with integer, this will act as a bitwise AND. So in this case, it's going to be 0. So you need to find out something like 0001 0010. Then apply this truth table. Okay. So this truth table, if both are 1, then only it's 1, otherwise it's 0. So in this case, you'll get 0, 0, 0, 0. Again, you need to multiply this one with 2 power 0, 0 times 2 power 0, 0 times 2 power 1, 0 times 2 power 2, 0 times 2 power 3. Then you need to add some, but in this case, all are 0, you'll get 0. Now, next one, like, let's see, either discount or coupon. So I'll use bitwise OR operator. Same thing, like you need to apply this one, the truth table, you'll get 3 here. Now let's see like the XOR operator. So if I want to have like only one of the discount or coupon, I will use this discount one. So this XOR operator. So on these bits, apply this XOR truth table, then you will get 3 here. And negation operator example, I want to find out not a discount. So I'll use this as discount and negate operator. So what is the value we have as discount is 1. And the result when we apply this symbol, you will get -2. So the simple rule is, example, I have a clock kind of a thing. I'll go with something like this. So example, if I have a 0, 1, 2, 3. So the 0 will have a -1, 1 will have a -2, 2 will have a -3, 3 will have a -4. So if you have a positive values, and if you apply negate operator, you will get negative values. So it's like a 0. If you have a 0, 0 plus 1, and then negate it. If you have a 1, 1 plus 1, 2, negate it. Or if you have a -3, so you need to go with like 3 minus 2, and you'll get -2, but you need to negate. If you do -2 minus of -2, it's become positive. Okay. Now the next one, we have a left shift operator and right shift operator. So as I mentioned, like these are good for multiplying or dividing by powers of 2. So if you have those kind of operations, you can use these operators. Example, I have something like a stock count equal to 8. Now I want to double this stock count. So instead of like stock count times 2, I will use stock count left shift by 1. I'll get 16. The performance very good. I mean, like when comparing with arithmetic operator, if you have a powers of 2, or I mean like multiplying or dividing by 2, if you have those kind of operations, you can use these left shift and right shift operator. Suppose I want to stock after halving, so I will use right shift operator. So it's like a 8 divided by 2, I'll get 4. The other operator is like the sign. So right shift sign operator, so it preserves the sign, like whatever the sign bit we have, whether it is a 0 or 1, it will preserve that sign bit as is. Okay. The next we have is ternary operator. So this is like a question mark and colon symbol. So this is like a shorthand for else if condition. This is very quick and elegant way we can use this one. So example, like think that I have in stock variable which is 0. Now I want to find out like the availability check for a stock. So what I will do is like I will use based on some condition. So in this case, like how it works is like if this condition is true, this will be assigned to this variable. If this condition is false, then this will be assigned to this variable. So in this case, stock is 0, 0 greater than 0, it's a false. So what happens is this string value will be assigned to availability variable. So if I try to access that variable later point, so I'll get out of stock. So this value. Okay. So instead of like if stock greater than 0, do in stock, else out of stock. So instead of writing if else, I can write this ternary operator. And if you want, you can write ternary inside ternary. So example, instead of writing this one again, if you want to write one more condition, do something, then I can write one more ternary here. Okay. Next operator is instance operator. So basically, like if I want to check a particular object is a specific type of, that means if I want to check like a product object is of type product or a string is of type string. We'll talk about what is object later part. But for now, just remember, if you want to check an object belongs to a specific class or type, then we use instance operator. So example, I have a variable called as a coupon code whose type is string. This is a variable and this is a data type. So far we were discussing about a variable and a primitive data type, right? And this is a variable, this is a non-primitive data type, and whose value is welcome 10. Now I want to check whether this variable or this object is of type string. So I'll go with coupon instance of string. So coupon instance of string. So I'm checking like whether this is of type string or not. Yes, the type is string. So I'll get true value here, and that will be assigned to this variable. Later, if you try to access is string, I'll get true here. That's it about the operators. So just to wrap up, we have covered like arithmetic operators, assignment operators, comparison, logical, unary, bitwise operators, ternary operator, instance operator, and right shift and left shift operator in the bitwise operators. Okay, that's it for this video. I'll see you in the next video. Until then, keep learning, keep coding. Thank you.